talked about this the other day, really as a way to lead into talking about empirical formulas. So we talked about distinguishing between empirical and molecular formulas. And you were able to find from %comp the empirical formula. Well, now we're going to talk a little bit more about the molecular formula and how you go back and forth between the two of them. So we talked about and demonstrated that you can have multiple compounds that have different molecular formulas but the same empirical formula. There's this multiplier effect. So if we look at the molecular formula, it's always equal to the empirical formula times some multiplier x. Okay? So if we take the example of something that has an empirical formula of CH2, and we know that the molecular formula is C3H6. What we're looking at is the relationship between this multiplier and the subscripts. And so you can visually really quickly see that, oh, the multiplier here is 3. Everybody sees that, right? Okay. And it's not, you're not multiplying C by 3 or H by 3. You're multiplying those subscripts. So it's sort of it's not quite a metaphor, but it's also not straight up math. Okay. Well, here's the thing. We can use a proxy here, because what's also true, if we copy this, is that the molecular formula mass is equal to the empirical formula mass times some multiplier x. What that allows us to do is, if we have the molecular formula mass and we have the empirical formula, we can figure out the multiplier. So with any two of those pieces of information, and typically what we're doing is going from the empirical formula to the molecular formula. So let's practice an example of this. If we have a compound and we're told, this is how this information typically comes to you. You're given the empirical formula. So we've got a compound. It is known that the empirical formula is CH2O. And we know that the molecular formula mass is 120.12 grams per mole. So what we'd like is the molecular formula. So where do we start? We want to remember this. So molecular formula mass equals empirical formula mass times that multiplier number. So if we can do that, can we find the multiplier? Do we have all the information we need to find that multiplier x? Okay. So for finding that multiplier x, what we're looking at algebraically is dividing both sides, I'm going to shorthand this, by the empirical formula mass, and that'll get rid of it over here. Okay. So, do you have the molecular formula mass? Yes. Do you have the empirical formula mass? You do? Did I give it to you? Can you find it? So, if you take the empirical formula and you find the molecular mass of formula mass of the empirical formula, well, we've got carbon is 12.01 times 1, hydrogen is 1.01 times 2, oxygen 16.00 times 1. What do you get? Oops. Okay, so we got our raw answer for the mass of the empirical formula. We're now going to plug those numbers into our equation. This is pretty simple, pretty straightforward. And what do we get for our multiplier? You can answer with your fingers because it's less than 5. Okay, 4. So you should be getting x equals 4. Well, if this is our empirical formula, what's our molecular formula? C4H8O4. And that's your final answer. Okay. What I would suggest is this. In the homework, there are some problems that just practice, oops, I'll go back to that, I'm sorry, that just practice that part of the skill. So, oh crud, that was your homework problem. Crud, I pulled that off the top of my head. I absolutely did not intend to do that. There are a limited number of organic compounds for which this works. Crud, crud, crud. Well, humph. Okay, so this is the empirical formula. Yeah. This is the molecular. Because that X is multiplying the subscripts.
Yeah, but
so
the empirical formula times X, so would you have to
because that's
take those from
1. No. So let's go back here. Let me make sure I didn't screw it up. Yeah, so the empirical formula in this example is CH2O times 4 for everything. Gives you your molecular formula. So we're multiplying 4 by the subscript there. Well, the subscript there is 1. So we get C4. Multiplying by 2, we get H8. Multiplying by 1 again, we get O4. Does that make more sense? Okay. So what we're given the molar mass of a compound, molecular mass, I should say. 233, number 5 in the section review. Okay, so the molecular mass of a compound is 92 grams per mole. A sample of this compound contains 0.606 grams of nitrogen and 1.390 grams of oxygen. Find its molecular formula. So we know that the eventual thing we're going to do is molecular formula, we're going to use the mass, is equal to the empirical formula mass times some multiplier x. Okay, great. And we were given this piece of information. This is really what we want. Well, what we're not given is the empirical formula. So you have to go all the way back to the beginning of finding empirical formula from percent composition. And, so before we can do this, we have to go from percent comp to empirical formula. Do we have the percent comp information? We do, it's just not put in terms of percent comp. So we're told how many grams of nitrogen and how many grams of oxygen there are. Can we use that to find out how many moles of nitrogen there are to how many moles of oxygen? Yeah. So we don't actually even have to go into the percentages, though typically you get percentage information. So if we back it up all the way to there, we can do this. And we can say, well, 0.606 grams of nitrogen is equal to how many moles of nitrogen? and 1.390, whoops, I'm sorry, 1.390, geez Louise Moser, 1.390 grams of oxygen is equal to how many moles of oxygen? I'm going to get rid of this stuff for now. Because remember, when we were given percentage information, we translated that percentage information into a number of grams. We just made our magical 100-gram sample. Here, we were already given grams, so we don't have to do that extra step of making the imaginary 100-gram sample. So go ahead and set these up. Grams nitrogen, grams oxygen, moles nitrogen, 14.01, 16.001, and 1. Get your raw numbers. Okay, so you've got the number of moles of each substance. Now, if you're going to try to find empirical formula, what's your next step? You're going to take the smallest number, which is going to be the moles of nitrogen, and you're going to divide each number by that. Okay, obviously we know that the mole, the subscript for nitrogen here is going to equal what? 1. It's dividing by itself. What's the subscript for oxygen? 2. So what is the empirical formula for this compound? Using these subscripts. So N with some subscript, O with some subscript, it's NO2. And we don't ever have to write ones, so yeah, we just call this, oops, and can you name it? This is a molecular compound. Nitrogen dioxide, right. So now we have the empirical formula. This is the empirical formula. From there, can you go to the molecular formula if you're given a molecular formula mass? Of course you can. So let's shrink a bunch of this. And what we have to remember is that the molecular formula mass is equal to the empirical formula mass times our multiplier x. So if we take our molecular formula mass divided by empirical formula mass, we're going to get that multiplier x. So what's the mass, empirical formula mass? I'm getting 46.01 grams per mole for empirical formula mass. We were told that the molecular formula mass was 92, and they used a really lousy number of sig figs. They just say 92, not 92.0. 92 divided by 46.01 gives us our multiplier. What do you get for your multiplier? 2. 1.99956, and it's got to be a whole number. So that equals 2. So what is our molecular formula? Well, NO2 multiplying all the subscripts by 2 gets us N2O4. Name N2O4. Dinitrogen tetroxide. Good. Okay, number 39 is like this, where you're going from, there you're going from percent comp information all the way up to molecular formula. And I'm going to do some sort of stepwise breakdowns here, so go ahead and try working on 39, and then we're going to revisit real quickly. Okay? Okay, I'm just going to go real quickly through this sort of stepwise process. When you're given composition information and you want to find empirical formula, step 1, if you're given comp as a percentage, make your magic 100-gram sample, turn those into masses. If you're given the comp as a mass, those are your givens. You don't have to do anything else. Your second step is just finding the number of moles of each element. Your third step is finding your ratios. Use the smallest number of moles and divide everything by that. And your fourth step and your final step, hopefully, if all of your ratios round to whole numbers easily, like, for example, 1.999 or 3.001, those are your subscripts. You're done. If they are on the halves, if it's like 3.49, you need to double. Okay, see you tomorrow.